Hey YouTube, it's JP Dillon. Welcome to part 2 of the Montgomery Wards Airline WG-5974. Yeah, 5974A. So, based on some comments from other people, I did pull and test a lot of components on the oscillator section here. You can see a couple of new caps. All those discs check out. I pulled the cap paralleling the coil there for frequency generation. The little molded pack there has to do with the sync circuits. That may or may not be affecting it, but I also changed the boost filter because it did have a slight amount of leakage, but not until it got to about 500 volts, and it's a 630 volt rated cap, so I changed it, but no real change. So I just disconnected the cathode from the horizontal out so that I could show you what the waveforms look like, because they look pretty good. They're just not fast enough. So here's my freeze mist. Anyway, watch the frequency counter. Starts out at 20 kilocycles. Pretty fast, right? Way too fast. Before it was dropping down to 10 or 11. Well, anyway, it's still hanging out there at 20. Nice looking waveform. That's how it should look. That's exactly how it should look. It's just too damn fast. Now, if I even so much as touch the adjustment coil, it goes down to 10, 10.9. But the amplitude goes up. You can see now that we have a big amplitude. And if we look at the waveform, still looks nice. Still looks real nice, but now it's too slow. And just as we found before, you can back the coil or back the slug all the way out, and it never achieves greater than about 12.5. That's where it tops out, and then the slug will literally fall out of the coil. And if you go too much the other way, you see the waveform break up like that, and we've got a double beat pattern, and then it just doesn't work. So, and then if I adjust the oscillator, we can see that it changes between 9 on the low end and 11 on the high end. So, really the next thing to do is to get a schematic diagram and to figure out what the voltages on the oscillator are supposed to be, blah blah blah. So that's what we'll do next. But for now, that's working. It's just at the wrong frequency. Alright, so I made a moment of discovery here. I put my AFC diode back in. It doesn't check good. It does have a little bit of reverse leakage in one section, so it will get changed out, but I just popped it in there for the sheer point of testing to see if that would change anything, but it didn't. However, I noticed while I was poking around that the oscillator frequency started going nuts. And I noticed that it was, twitching, bouncing all over the place. And I noticed that the voltage on the oscillator control up here, let's see if I can actually get this to cooperate, kept changing a bunch. And it's not a high voltage. I think it's like a cathode adjustment type thing. So anyway, it was 0.7 and it's all over the place. And you can see that my horizontal is now jumping all over. So, but here's the thing. I followed this control down this wiring harness to this unmarked potentiometer here. And all I did was touch it with the screwdriver. You can see that it's just going nuts now. So that's just touching it. So let me clean this pot really quick. If it's going to be this simple, I'm going to feel real stupid. So let's just clean it. That's like a ultra coarse horizontal frequency control or something. Yeah. Well, anyways. So that's pretty huge. Look at that. That's like major oscillator control there. So let's see if we can dial it into 15750. Ooh, that's touchy. Alright, well, let's get it close. Let's set the coil back in where it was. There we go. Alright, 15. Exactly 15750. Okay, cool. Let's reattach the cathode on the horizontal out and see what it does. Alright, got the cathode lead of the horizontal output hooked back up, and we had a nice waveform and proper frequency response. So let's see if now we actually get proper drive. We'll see what happens. Oscillator's trying to start. Ah, there we go. I can hear the high voltage. We're at 15.4 right now. Let's see if we can tweak it out a little bit. $15,750. We get a nice big, and I mean big, waveform there. It's a little dirty, but not too bad. Oh yeah. A little parasitic artifact there. We'll have to see what that looks like when we get it on the screen. And man, that's like a really touchy adjustment. So the horizontal hold all the way at max yields 16, and then all of a sudden it just drops and we lose our high voltage. Now it's back to 11 again. Yeah. So that's kind of touchy. It's interesting how it pisses that off. So it's 15.4 to 16.4, and right in the middle is about where it likes it. But you get that breakup there when you get below 15.5. So let's see if we can change that somewhat, adjusting the oscillator coil. Take some of those parasitics out. Because I don't like how that looks. We're starting to double up there, getting too fast. That's all the way at one extreme. That's about halfway. 15 on the low side, 15.8 on the high, with the horizontal hold control on the top. And let's see, we're about at 15.7. 770, 760, 7. This drops down to 710 there. 747 is pretty close. And goes up to 17, goes as low as 15.2. That's a big difference. That's your breakup point there. Don't like that. Let's see if I can adjust the waveform coil to make that a little happier. Yeah, I don't like that. Let's see if we can clean that up a little. And let's readjust our oscillator voltage. Starting to look a little more clipped on top. 24, wow. That's a little fast. So this is like way too fast. Let's turn that down a bit. $14.6 to 19, that's too broad. Basically want to get down to where it starts to break up. Okay, so 13.9. Okay. And so let's see if I can clean up the edges here a little bit. It's not really doing a whole lot. We're looking for that peak point. Let's see if I can get it to sync there. So what I'm trying to do is adjust for symmetry here. And let's reduce this somewhat because we're already at 17K. Nope, doesn't like that. Wants to break up there. So we'll reset that back to where it was. Yeah, gotta remember not to touch the high voltage lead. Stupid. Alright, so at the bottom of the coil we have no change. And then we start to really change. It's a big difference. So doesn't want to sync on that no more. And when we get this ringing problem here, you can see it don't like that. Parasitics. So really, I need to play with this a little more. That's with it all the way backed out. So about a third of the way up from the bottom is where it yields the biggest change. So I'm going to set my adjustments for that. $7.48, $15.4, $16.2. All right, there's our horizontal range. At the lowest, it's $15.4. At the highest, it's $16.2. that's pretty decent. We won't know for sure until we put it back in the set. But that waveform looks good enough to use. I'm going to go ahead and try to dig up some Schottky diodes to replace the AFC thing. The waveform looks stable, so it's not dead yet, but the fact that I had so much reverse leakage on one direction says that we got to change that. But so far, let's see here, we're looking at 15, 753, 54. You can get it pretty damn close. So yeah, it was something that simple. I should note the other location of that pot and clean that one, because it's not labeled on here. So I'm going to make some notes and put labels on there. And then this is your vertical stuff, but we know that's running. So far so good. Looking much better. Love it when it's the simple things. Chase your tail for a bunch only to find out that it was the idiot thing that you missed. Happens to the best of us. Hear the Corona hissing away there. Okay. Let me go dig up some diodes for this thing, and we'll see if we can get it done and get it back in the set. Alright, so I robbed an old switching power supply and found some Schottky diodes here that are at the oscillator section, so I assume that they're fairly high speed. On my old VOM, they don't show any leakage, so I'm just going to verify that these are in fact diodes of some kind, and then I'll just make a little AFC diode out of these two to stick in there. Okay, and we'll just check the other one really quick. This thing will stop jumping around on me. Okay, so that's happy. Let's put these two together. Okay, there it is with the cathodes joined. And here it is with the changed lead extension, which I'm about to heat shrink. And there it is with an improved footprint. And there it is all happy and heat shrunk up. So now this is more or less ready to go back into the board. Let me just do a quick validation of the what it is. I don't know, I've never actually tried to do seen the results of a dual diode thing on here. I really should have chose different wire for this stuff. This wire is way too stiff. Alright, let's see what it thinks. Yep, so cathodes are joined at number 2, how I would think. Wonderful. Let's go ahead and pop it in the chassis. And there it is, all installed in the board. Let's wire this thing up real quick and see if it's still happy. Alright, got it all wired up. Moment of truth, let's see what it does. Waiting for that oscillator to start. There we go. 15,576. It does affect that somewhat. Let's make sure I got this hooked up right. No high voltage. Interesting. Pretty sure I got that right, but obviously our waveform is all jacked up now. That isn't right. It's inverted. Okay, so not doing that. What's going on here? Too fast? It looked fine before I messed with it. Alright, so that part comes out. Alright, thankfully just a loose connection there. We're running a little bit fast, 15.8. to 16.2. Let's turn that down a smidge. $15,750. Alright, it's pretty stable too. A lot more stable than it was. It looks pretty happy. We got high voltage. Hey kids, you want to see something cool? So, nice strong high voltage there, obviously. So I think this thing's ready to go back in the cabinet. What do you think? I'm going to mark whatever that is, take some resistance measurements and clean that. And then I think this thing's ready for another try at prime time. So that'll be on the next video. Anyways, thanks for watching. More stuff to come.